Hello everyone, this is Group 30 and this is a video demonstration for Lab 9 working with multiple internets of things. So what is the objective? Objective is to understand the end-to-end IoT solution, post data on ThingsBoard directly from Termux, use Python for sensor data management, monitor pressure using different IoT in real time, retrieve and visualize data from ThingsBoard IO. So the setup, for the setup we use 3 Android phone, and out of those one had an inbuilt pressure sensor and two was without inbuilt pressure sensor. So how we managed to have a creative way to get pressure sensor data is explained further in next slides. And apart from that, we definitely need a stable Wi-Fi connection. So to get pressure sensor data, we use something known as ideal gas law to generate the rate of change of pressure with respect to gravitational force present there. So this is a proof of ideal gas law which we used. So this is a Python script to send pressure sensor data without the inbuilt pressure sensor. So as you can see, uh, we got the pressure using the ideal gas law overhead. We use the constant values, and this is the Python script to send data with inbuilt pressure sensor. So as you can see, we directly send the pressure sensor data. So this is getting data on ThingsBoard IO. These all code will be explained later in the video. So this is a logging of data in ThingsBoard IO. So as you can see, we have longitude, latitude, pressure, and timestamp. So for visualization of data, we use an Python library known as Folium. So Folium is a Python library that simplifies the creation of interaction map with the help of easy integration of Leaflet.js map with Python data. So the key features of this program is like it has interactive map, data visualization is there, and it is very easy to use. The use case in our lab is generating an area pressure map from IoT sensor collected across different locations. So how we displayed the data, first we went to the tutorial of Folium, learned about it, and then we create an HTML map to generate HTML code to display area pressure map, and source code is included in the next slide. So this is a source code for displaying data in Folium. Again, this will be explained later. So this is a screenshot of one device. This is a screenshot of a second device. As you can see, there is a different distribution of pressure with according to this graph. This is the pressure sensor data from third device, and this is like having pressure sensor data all three at the same time. So the key takeaway from this lab is like effective data collection and visualization, automation of sensor data posting, integration of multiple IoT devices. And this lab actually uh, becomes a fundamental for our final project as well. So that's it from the PPT demonstration, and next we'll go for video demonstration. Thank you.
Hello guys, welcome to my part in the lab 9 of W542. So here basically first I navigate to VS Code to show you the code where we basically get obtain data. We basically extract the data from the gravitational sensor and convert it into pressure using formulas. Okay, so this is the conversion code which basically displays all the constants that we use to, and finally we convert the gravitational sensor reading to pressure reading, and finally we upload all those we log all those data sets to ThingsBoard. Okay, now let us navigate to the next code, which basically gets the data from ThingsBoard, and it stores the data. It stores the data in a data.json format. In a JSON format, the JSON format is useful for uploading the data set to Folium, which is a visual representation of your uh, pressure values, visual representation. Okay, so this is the getSensor.py, which is used to obtain data, collect data from ThingsBoard, and then finally store everything in a JSON format, which we can see. So the format is JSON. Okay, so now let us navigate to the JSON file and see how it looks. So this is how it looks. type features, geometry, coordinates. The coordinates are basically the latitude and longitude, and then we have pressure values. Okay, and finally, this is the code for uploading our data set to JSON, data set to Folium. So using Folium, we can finally visualize our data set, how the pressure value is for the three different phones at every point in time, at every position. Basically, three positions because we use three mobile phones. Yeah, thank you.
Hello guys, so now we'll look into the output verification part for E542 Lab 9. So in this exercise, we were asked to collect data for latitude and longitude and a pressure value in a particular point from our phone sensors. So we had used three sensors. We had used three devices to collect all of the data. Two of the devices don't have pressure sensors and the one had pressure sensor. So we also explained how to collect pressure value without exactly using the pressure sensor in a phone. We could use the gravitational sensor for it. So here in this part, I'm here to demonstrate the Folium part where we take in the data and then plot it as points in our map and then create the Folium map. Yeah, so we already have the collected points as a data JSON here. So we could observe that there is a small variety in the values that are being changed. So in this Folium code, we load the JSON data and then we create an empty list called GeoJSON collections because the data being collected in the JSON file is of the GeoJSON format type. So we'll restructure them in the format of GeoJSON and then the name of the collection. After that, we'll create the map center. This map center is centered at Los Angeles. So this is the centermost location. After that, we use the Folium function of create map with point collections, and then we plug in all of our collections and the center part from where the collections are displayed on the map. The property for color is pressure. So we've chosen the pressure value to show the output. The map is saved as a HTML file. So this is the thingsboard.io page where we get the data. So we get the different latitude, longitude, and pressure values here. Yeah, so this is the output screen where we could see that there is a difference in pressure at two different points within the same place because two of our teammates are here. So in this particular area. After that, one of our teammate is in this particular area. So the pressure value obtained in his cell phone is shown here. So these data are collected. Basically, the latitude, longitude, and the pressure areas are collected. Two of the phones don't have pressure sensors. So a formula is used to approximate the pressure sensor value, which is then saved as a GeoJSON file, which is shown here. So this concludes the output verification part for Lab 9. Thank you so much.